You know, when we hear the term spy plane, most of us immediately picture some sleek, black jet just streaking through the upper atmosphere. But what if I told you that the modern reality is a whole lot less about a single plane and way more about a flying, thinking network? The world of aerial reconnaissance today is so much more complex and, frankly, more fascinating than you probably imagine. So let's dive in.
So what is the job of these incredible machines today? It's really not just about taking a few pictures, it's about building a complete, real-time understanding of some of the most complex and dangerous environments on the planet.
At its very core, the mission has always been the same. It's to cut through all the confusion, the uncertainty, the chaos, what we call the fog of war, and deliver crystal clear clarity to the commanders who need it. Now, to actually accomplish that, the military has a very specific term for this whole mission, and it goes way beyond simple spying. Let's break down exactly what that is. Okay, it's called ISR. That stands for Intelligence, Surveillance, and Reconnaissance. The best way to think about it is as a three-step process. Intelligence, that's the big picture, understanding what an opponent is even trying to do. Surveillance, that's the long-term, persistent watch over a specific area. But reconnaissance, that's more active. That's about going out to find the answer to a very specific question. You put them all together, and that's how you turn raw data into a clear picture for decision makers.
So how do these aircraft actually build that picture? Well, they use this incredibly sophisticated toolkit of sensors that allows them to see, hear, and even sense the battlefield in ways that are, honestly, almost superhuman.
First up is something called IMINT, which is short for Imagery Intelligence. Just think of this as a super camera on steroids. It uses these unbelievably powerful optical and infrared sensors to grab crystal clear images, whether it's broad daylight or the dead of night. It can see right through smoke and bad weather to show you exactly what's physically on the ground. Next on the list is SIGINT, or Signals Intelligence. This is pretty much the eavesdropping layer. These sensors, they don't look, they listen. They're built to intercept radio chatter, radar pulses, and all sorts of other electronic signals. This lets analysts map out where enemy forces are and sometimes even figure out what they're about to do next.
And then we get to MASINT, Measurement and Signature Intelligence. I mean, this is where it becomes pure detective work. MASINT sensors aren't just looking or listening, they are sensing. They hunt for unique physical clues, things like the specific heat signature of a tank's engine, the chemical trail from a missile launch, or even the vibrations from an underground facility. It is all about finding the unseeable. So there's your complete toolkit. You have IMET for seeing, SIGINT for listening, and MASINT for sensing. But okay, how do you make sense of all that data flooding in? Well, that's the job of AEWNC, or Airborne Early Warning and Control Aircraft. Think of these planes as the quarterbacks in the sky. They're flying command posts that fuse all this information together and direct the entire team. You know, for decades, these extremely dangerous missions were flown by pilots at incredible risk. But right now, we're in the middle of a massive shift, a huge debate between putting a human in the cockpit or, well, letting an unmanned system take all the risk. And right here, this is the central trade-off in modern aerial reconnaissance. On one side, you have the absolutely irreplaceable creativity and adaptability of a human pilot who can react to something completely unexpected. But on the other side, you have the sheer, tireless endurance of a machine, a drone that never gets tired and can stay on station watching for days at a time.
So let's see how this plays out with some real aircraft. You've got the U-2 Dragon Lady, which is still flown by a pilot. Why? Because it can carry these huge, incredibly complex sensor packages that drones just can't handle. Then you've got the RQ-4 Global Hawk, which is all about that endurance. And then there are tactical drones like the Reaper, which get up close to watch specific targets. And of course, you had the legendary SR-71, which was built around one thing: pure, mind-bending speed.
And this is the absolute game changer for unmanned systems. An aircraft like the RQ-4 Global Hawk can stay in the air for over 30 hours straight. That provides something called persistent surveillance, an unblinking eye that a human pilot, no matter how skilled, simply could not match.
But then you've still got the manned U-2. So why is it still flying after all these years? Because it operates at over 70,000 feet. We're talking the very edge of space, carrying these massive, cutting-edge sensors that really need a human on board to operate effectively. It fills this very unique niche that drones haven't quite mastered yet.
All of this brings us to a really fundamental change in military philosophy. See, the goal isn't necessarily to be the fastest plane in the sky anymore. It's about having the smartest sensors.
The old way of thinking was personified by the SR-71 Blackbird. Its main defense was just its unbelievable speed. Flying faster than Mach 3, it could literally outrun a missile fired at it. But modern air defenses have gotten so advanced that that approach is now almost totally obsolete.
And that leads us to the modern doctrine of standoff distance. So instead of flying directly over a dangerous target, aircraft now stay hundreds of miles away, safely in friendly airspace. And from there, they use these incredibly powerful sensors to look sideways, deep into enemy territory. It's the perfect example of working smarter, not harder, or in this case, smarter, not faster.
Okay, and this is where it all comes together. A modern reconnaissance platform is not acting alone. It's a node, a single point in a vast flying information network.
Think about an advanced fighter like the F-35. We think of it as a weapon, right? But it's just as much a data-gathering platform. Its sensors are constantly vacuuming up information about the entire battle space, which basically makes it a flying server in a massive airborne computer network.
And this is how it all works. A sensor on one aircraft detects a potential threat. That data is then instantly, and I mean instantly, shared across a secure data link to every other friendly asset in the area, other jets, ships, even soldiers on the ground. Suddenly, everyone sees the exact same picture in real time. It's like a high-speed, encrypted internet flying at 30,000 feet.
A great real-world example of this is the Indian Air Force. They operate a really sophisticated layered system. It combines their own domestically built AEW&C command and control planes, other powerful AWACS platforms, and a large fleet of surveillance UAVs. Each asset is a different piece of the puzzle, and they're all working together as part of this bigger network.
And that right there is the single most important thing to take away from this. The era of the lone spy plane is over. Victory in the modern information war is going to go to the side that can best connect all of its sensors into a single, cohesive, and intelligent network.
Which leaves us with a pretty fascinating final question. We've already seen the shift from human pilots to remote-controlled drones. So as artificial intelligence becomes more and more capable, will that classic trade-off between human expertise and machine endurance finally be decided for good? Will the next generation eye in the sky even need a human in the loop at all?